BioMADE backs bioindustrial scale-up and supply chain growth. BioMADE's latest project round suggests the U.S. bioindustrial manufacturing sector is moving beyond early-stage promise and toward more commercially focused priorities. The organization announced $21.4 million in funding across 14 projects, supported by federal defense funding, the National Science Foundation, and non-federal cost share. The portfolio covers bio-based materials, lithium recovery, fermentation optimization, life cycle analysis, domestic feedstocks, and workforce development. For environmental and energy markets, the funding reflects a clear direction: using biology to support domestic supply chains, reduce dependence on imported inputs, and create lower-impact production routes where the economics can stand up at scale. Waste streams and domestic inputs take priority. One of the most commercially relevant projects is Alkali Labs' work on lithium biomining. The project will develop and validate a microbial process for extracting lithium from produced water, a byproduct of oil and gas production. For battery supply chain stakeholders, this matters because lithium demand remains a pressure point for energy storage, electric vehicles, and broader electrification. Recovering lithium from existing industrial waste streams could help companies view produced water as more than a disposal challenge, provided the process can prove efficient and scalable. The portfolio also includes work from Mango Materials and the University of California, Davis to produce PHA biomaterials from methane gas. The project focuses on improving downstream processing efficiency, a key cost barrier for bio-based materials used in applications such as films, fibers, and 3D printing. The commercial test will be cost, consistency, and market readiness. Still, the direction is notable. Converting methane, a high-impact greenhouse gas, into usable materials could support more circular manufacturing models for selected industrial applications. Other projects focus on domestic feedstocks and verified environmental performance. Checkerspot will examine feedstocks for precision fermentation, while Boundless Impact Research and Analytics, an invasive species corporation, will develop life cycle analysis resources for biopesticides. That data will be important for corporate sustainability teams. Bio-based products are not automatically lower impact. Buyers will need credible information on emissions, sourcing risks, land use, energy demand, and end-of-life outcomes before making procurement decisions. Scale up, data, and workforce will decide commercial value. Bioindustrial manufacturing is increasingly being judged on practical delivery rather than concept-stage innovation. BioMADE's project list reflects that shift, with several initiatives aimed at the tools and talent needed to operate at industrial scale. Boston University and Capra Biosciences, for example, will work on free-floating microbial electronic sensors inside bioreactors. The aim is to generate better data from fermentation systems, which could support AI and machine learning for process optimization. That type of infrastructure may be less visible than a new bio-based product, but it is central to commercial production. Companies need more predictable yields, tighter process control, and lower operating risk before biomanufacturing can compete with established industrial routes. Workforce development is another major theme. Projects led by MIT, Manus, and the University of Georgia, Dakota Bioworks and South Dakota Biotech, and UC Davis with community college partners will focus on apprenticeships, undergraduate training, veteran career pathways, and regional education programs. This matters because the bioeconomy will need more than scientists. It will require technicians, operators, engineers, and plant teams who can manage facilities safely, consistently, and efficiently. For rural and regional economies, the workforce element could be particularly relevant. If bioindustrial manufacturing creates new demand for agricultural feedstocks and domestic inputs, it may also support manufacturing jobs closer to where those resources are produced. The wider takeaway is that BioMADE's funding round positions biomanufacturing as part of a broader supply chain and industrial competitiveness strategy. The environmental case will depend on execution, especially around feedstock sourcing, energy use, scale, and verified life cycle results. But the projects show where the sector is heading, toward waste recovery, domestic production capacity, and more disciplined commercial deployment.